which is over translation. So again, I showed y'all the formula chart. It is posted above all the notes in Canvas. It looks like this. So it has translations on it as well. So we talked in 6.1 about reflections, and that FL can help remind you that it means flip. Rotations, that T can help remind you that it means turn. And then for translation, that SL in the middle hopefully will help you remember that this means slide. Okay, so all three of these that we're learning in Unit 6 are rigid transformations, meaning they keep their congruence. Okay, they maintain the size and the shape, unlike dilations. Okay, so I'm going to put slide in parentheses there. So a translation is just sliding the image around the coordinate grid. Okay, so this says to use translation xy to x plus 6, y minus 3. So this is the rule. Okay, they want you to take your original point and move it by adding 6 to the x and subtracting 3 from the y. Now, I showed the transformations on the formula chart, but I'm going to put it up here on the top of the notes as well. Your x is going to be plus or minus some number, and your y is going to be plus or minus some number. We use h and k for those. That just tells you the direction that you're sliding. We know that the x-axis goes left and right. So if you're adding, you're going to the right. If you're subtracting from x, you're going to the left. The y-axis goes up and down. So if you're adding to the y, you're sliding up. If you're subtracting from the y, you're sliding down. Now you may do both, you may do neither, or one or the other. But let's look at these examples. So in the first one down here, it says, what is the image of A? Okay, remember, pre-image is what you start with, image is after. So you go, if you need a reminder of that, you go pre-image to image. Okay. So if we start with 3, 2, where do we end up after applying this rule? So we call the image, we put a prime. So if A is the pre-image, A prime is the image. And I'm adding 6 to my X. So that's a 9. And I'm subtracting 3 from my Y. So that's a -1. And that's it. It's literally just adding and subtracting in the right place. Okay, so number 2 says, what is the image of B? Again, we're going to add 6 to the X and subtract 3 from the Y. So B prime will be at 2, -2. Now 3 and 4 says, what is the pre-image of C prime? So they're telling you the value or the location after the translation. So we have to go backward. So if we're going backward, we're going to do the opposite of the rule. So 2 is what we got after we added 6. So to go backward, we'll subtract 6. -7 is what we got after we subtracted 3. So to go backward, we'll add the 3. So to go backward from the image to the pre-image, you do the opposite, addition or subtraction. So that means C was at -4 before it was translated. Same idea here. What is the pre-image of D prime? Well, we'll have to go backward to find that. So we will subtract 6 and add 3. So it started at -9, 1 before it was translated, before they slid it around. Okay. Now, when you're applying translations, it wants us to complete the statement using the description of the translation. So this, when we talk about a rule, it's written here like this, with the X, Y, and then an arrow, and then what you're doing to your X and Y. Now, when you write a description, you're just saying up, down, left, right, okay? So we're going, it says in the description, 0.03 and 2.5 are 2 vertices of a hexagon. So if 0.3 translates to 0.0, then 2, 5 translates to what? Okay, so we're going to look at the change to come up with what the change was and then apply it to the other point. So to get from 0 to 0, it didn't go anywhere. So that means nothing happened to the x. So it stayed x. But then the y changed from 3 to 0. So we subtracted 3 from the y. So that's the rule that was applied. If 0, 3 translates to 0, 0, that means it didn't go left or right any, it went down 3. So I'm going to describe that went down 3. So my new coordinates for 2, 5 would be for 2 to stay the same. And if I go, if I subtract 3 or go down 3, that'll be at 2. So that'll end up at 2, 2. So same concept here. If 0 ended up at 1, that means we added 1. If the y started at 3 and ended at 2, that means we subtracted 1. So here we went right 1 and down 1. So this new point from 2, 5, if we go to the right 1 and down 1, we'll be at 3, 4. Okay, one more like that. So the x goes down or to the left 3, subtract 3 from the x, and then the y went down 5. So I wrote this one in words, or both of these in words. You could also just use arrows. So minus 3 from the x means left 3, minus 5 on the y means down 5. So you're fine to use arrows as well if you like that better. So this 2, 5, if I go left 3, I'm going to end up at negative 1. And then I start at 5 and I go down 5, I'm going to end up at 0 for the y. Okay. Then that's the same color as the rest. These are black. Okay. This next section says, okay, a point on an image and then translations are given. Find the corresponding point on the original figure. So the image is after. So we're looking, find it on the original figure, we're looking for the pre-image. So if this is the image and this was the translation used, we have to go backwards. So this is like what we were doing up here in red. Okay, so to get to 4, 0, they added 2 to the x. So I'm going to have to subtract 2 from the x. They subtracted 3 from the y to get to 0. So I'm going to have to add that 3 back in. So that means the pre-image was at 2, 3. So it started at 2, 3. This rule was applied and it took us to 4, 0. So same concept here. This time, oh, this one's not a translation. I don't know why it's on here. This is a reflection. I'm going to put a star next to this because this is not a translation. We talked about reflections in 6.1. Okay, so if x changes but y stays the same, that means this is reflected over the y. So if this is reflected, this was reflected over the y, I go back over the y, and it would be the x wouldn't, the x sign would change to back to positive 3. The y wouldn't change. Okay, and then this last one, the translation is subtracting 7 from the x. So to go backward, I'll have to add 7. Subtracting 4 from the y. So to go backward, I'll have to add 4. So my pre-image would have been at 13, negative 5. So it started at 13, negative 5. This rule was applied and it ended at 6, negative 9. All right, now on the coordinate grid, We're gonna graph the triangle. So -1, 1, there's A. 4, -1. There's B. And C is at 2, 4. Okay, so here is our pre-image. This is what we're starting with. And they want us to translate it. So graphically, when you're translating, you're just moving, sliding it around. So they want us to slide the X left 3, because X minus 3. So I could take all of my X's and go 1, 2, 3 over. And they want me to take my Y's and add 5. So that we go up 5. So then those points end up, this is my A prime, C prime, and B prime. So I slid that figure left 3, up 5. I just took each coordinate and did that. So graphically, you can do it like this. Okay, so this one I'm going to start with my pre-image, same place. So -1, 1, 4, -1, and 2, 4. This time, they want us to go left 4. And now I'm doing all the left movements and then all of the vertical movements just because I'm color coding this. But most of you would probably just do 1 point at a time. You would say, okay, this is left 4, down 2. So you would just go left 4, down, oops, left 4. Again. Down 2, left 4, down 2, left 4, down 2. And you would plot those probably one at a time. Seriously? So there's A prime, B prime, C prime. Oh, I never drew the lines for the original. Oops. There it is. So you can see this triangle ABC went left 4, down 2. You want to add those in words or with arrows. That was left 3. That was left 4. This was up 5. And this was down 2. All right, now this one says that the prime, the image, is after translation of ABC, write the rule. So they give us the graph, they want us to write the rule. So I'm just going to come in here and I'm going to count. Okay, I'm going to count how far over and up or down are these points. So you can go A to A, B to B, C to C, it doesn't matter. Okay, but for B, I'm going to do this way here. So I would just simply count and say, okay, I went 1, 2, 3, 4, 5 to the left. And I went 1, 2, 3 up. So that means my rule for the X and the Y, I went left 5, so I'm subtracting 5, and I went up 3, so I'm adding 3. So that's my rule for this translation. So same idea here. So let's measure or count. And I know you can do this without drawing it in there, but for your notes, I want to have it drawn. So, you know, where we got these numbers. So I'll go A to A. You could go B to B, or you could go C to C. It really doesn't matter. So from A to A prime. Oh, actually, I almost just messed us up because I went from A prime to A. That's going backward. So be careful. You need to go from A to A prime. So I would be going to the right. Get these dashed lines correct. I would be going to the right and down instead of left and up. So that would have given me the wrong signs. So this is going down 1, 2, 3, 4, 5. So that's subtracting 5 from your y. And it was to the right 2. So it's adding 2 to your x. So from A to A prime, I went right 2, down 5. Okay, and this one from B to B prime, I did that. And you could check them all. You don't have to, though. They should all be the same translation rule, or they're not similar or congruent. And that's it for translations. And again, you've got the formula chart that I showed y'all. It's posted in Canvas above all of the notes. So you can always pull this up and reference this if need be. And you've got your practice. Let me go here. So all of these are going to be right here. This is 6.3 I'm recording right now, so I'm about to add it right here. But you've got 6.1 video and completed notes, 6.2. I'm going to add 6.3, and then this is the actual assignment that you need to do.